All right, good morning. Uh, Today we are going to do our last day of integration by substitution notes. All right. And it's going to be all with trig. Okay. Now, what you need to remember with trig, what we've done so far is anytime we only have one trig function, or we have two trig functions, like in example 14, but they are the same power to the first, we always make u what comes after the trig function. So the last example we did the other day was 14, and we made u x cubed. All right. So I told you we'd start with this one today, and that's what we're going to do. We just have one trig function, secant. All right. Even though we have all of this other stuff going on, all right, I don't care about that. I have one trig function. I'm going to make u whatever comes after it. So u is going to be 1 over x. All right. Now, we'll go through and find our du. Now, to find the derivative of 1 over x, I'll just write this up here. Remember, 1 over x is really x to the negative first, which if I took the derivative of that, it's negative x to the negative second, or negative 1 over x squared, right? Because I moved the negative 2 to make it positive, move it to the bottom, dx. All right, so the derivative of 1 over x is negative 1 over x squared. All right, so we want to make sure all of our du is in the problem here. All right, so there's our dx. We have a 1 over x squared. All of this right here. The only thing I'm missing is the negative. Well, that's easy enough. Just add a negative to the outside. That's it. Add a negative, you're good. Because if I add negative 1, or to the reciprocal of negative 1 is negative 1, right? Negative 1 over 1, if I flip it, it's 1 over negative 1, which is still negative 1. So you just got to add a negative, and that's it. So to rewrite this, it's negative integral. This and this are my du. And then secant squared u, right? Because this is u. So the integral of all of this just turns into a nicely easy integral. So when I integrate, I get secant squared. What derivative of what is secant squared? All right, that is tangent. So it's negative tangent u plus c. All right, so negative tan of 1 over x plus c. And there you go. All right. So now, all right, we're going to do these problems here. And if you notice, a lot of these, almost all of them, have multiple trig functions in them. Okay, so for this first example, we have a cosine and we have a sine. Now, what I want you to notice is that the cosine, this power is 3. All right, this one, the power is 1. They're not the same. If they were the same, then we would probably make u 5x, whatever comes after the trig functions. They are not the same. So we're not going to make it what comes after it. What we're then going to do, this is going to be a little different. We're going to have a trig function in our u. All right, so we're going to pick. So it's either going to be cosine 5x or sine 5x. That's going to be your u. You are going to pick the one that has the highest exponent, which 3 is bigger than 1. Which one has the 3? The cosine does. So we're going to make our u cosine 5x. All right, so u is cosine 5x. All the same steps after that. All right, the derivative of cosine. So you got to be careful, chain rule. And this is where everyone makes a mistake. So it's going to be the derivative of cosine is negative sine 5x, because the inside stays the same. So take the derivative of cosine, negative sine. Keep the inside the same. This is where everyone forgets. You have to multiply by 5. All right. So all of this is my du. Negative sine 5x times 5 dx. So right here is almost everything that I need, right? There's my sine. There's my 5x. There's my dx. What am I missing? A negative and the 5. Well, real easy. Just put a negative 5 in there. which means what goes on the outside? A negative 1/5. Now, what's left? We have cosine 5x to the third power. Remember, when you have a power like that, this is the same thing as cosine 5x, that whole thing being cubed. That's what this means. So, but what is cosine 5x? That's our u. So all of this just becomes u cubed. All of this in the pink box is my du. So we have something that look really, really like a pain in the butt, and now it's just this, which we know how to integrate this nice and easily. Negative 1/5 u to the fourth over 4 plus c. And then we write this as negative cosine 5x, sorry about the writing here, to the fourth. If you want to put the 4 between the cosine and 5x, that is also fine, over 20 plus c. And there's your answer. All right, negative the quantity cosine 5x at fourth power, all over 20 plus c. All right. Now let's look at number 17. Once again, we have sine, we have cosine, two trig functions. They have different powers. Sine has 2, cosine has an exponent of 1. So what is going to be my u? Well, we're going to pick the one that has the higher exponent, which is 2. So it's not just going to be 2x. We include the trig function. It's sine of 2x. We then take the derivative of sine of 2x. The derivative of sine is cosine. Keep the inside the same. Times the derivative of the inside. Don't forget about the 2. If you're going to make a mistake, that's where it comes. All right. So now we need all of this in here. Well, I have cosine 2x dx. I'm missing a 2. So just add it there. And then this all right here is cosine 2x 2 dx. That's our du. Put a 1/2 on the outside. And I'm left with sine 2x squared, which is just u squared. Du, which is 1/2 u cubed over 3 plus c. And then it's sine cubed of 2x over 6 plus c. Now, notice in these two examples, all right, this answer, I put it the quantity raised to the fourth. This one, I did the 3 there. I did them differently to show you I don't care which way you write it. They are both correct. Whatever which way you want to write it, great. Okay. Another thing I want you to notice, these problems, when we do these trig problems, u has a trig function in it. But when I do the substitution, there is no trig in here. Notice trig here, no trig here. All right. Whereas in the ones we did the other day, and in this one, here's a trig problem. The u doesn't have the trig, but the integral, when I rewrite it, still has the trig. And that's always going to be the case. If you have trig here, you're not going to most likely have trig there. If trig is in your u, you're not going to have trig in your integral. Okay. Okay. Now, what I would like you to do is I would like you to look at number 18 and see if you could come up with the u, the du. All right. If you at least get the u and the du, that'd be great. See if you can get the whole integral by yourself, and then see if you can get an answer. All right. I'll give you a second to do that now. All right. So let's see how you did. Once again, 1, 2 trig functions. Different powers. This one's squared, this one's to the fourth. So that means that a trig function is going to be in our u, either secant 3x or tangent 3x. We're going to pick the one with the highest exponent. That's 4 is bigger than 2. So tangent 3x is going to be our u, which means our du. What's the derivative of tangent? Secant squared 3x. All right. And then I need to multiply by the derivative inside, which is 3 dx. All right. Remember, derivative tangent is secant squared. Keep the inside the same. 3x multiplied by the derivative inside is 3. All right. So we need all of this to be in here somewhere. Secant squared 3x. Look, it's right there. Dx is right here, but what am I missing? I do not have a 3 anywhere in this problem. So I add a 3 there, which means I put a 1/3 on the outside. All right, now, everything that I've circled here in purple, that is all du, right? That's just du. The only thing that's left is tangent 3x to the 4th power, but tangent 3x is u, so it's just u to the 4th. So this, which looks like a real ugly problem to start, is now just 1/3 integral u to the 4th du. So it's 1/3 u to the 5th, over 5 plus c. So it is, remember you have the option here of putting tangent 3x in parentheses if you so desire, or putting the exponent between the tangent and the 3x. So tangent 3x to the 5th over 3 times 5 is 15 plus c. All right, and there is our answer. Okay, now 19. All right, 19, we have two trig functions. Okay, we have sine, we have cosine. They are not the same power. All right, they are not the same power. This is 1. This is actually a half. Now, you might be thinking, well, since the 1's bigger than a half, shouldn't I make it sine 4x? Well, here's the deal. Go back to what we first started doing with substitution. Whatever was on the inside. If you have a situation like this where it's underneath a radical, pick what's on the inside, but it's going to be the entire thing. So it's going to be u cosine 4x. Okay. Now, the derivative of this. All right. Now, I do have a little surprise for you. All right. I'm going to be putting on the classroom a formula sheet. All right. This formula sheet is like gold. All right. Well, the good thing is you won't lose it because it's on the classroom. So I'll keep it up there. But it has so many formulas on it, and it's going to have all of the derivatives and all of the integrals for all the trig functions, along with a lot of other stuff that you're not going to know what it means yet. But it's going to have the derivatives and the integrals. And I'm going to attach that. So you're not, yes, you should know all these derivatives and integrals, but I'm going to give this sheet that hopefully when we get back to school, you'll be able to use on any quiz or test we have for the rest of the year. Obviously, any assessment that you're doing online for the rest of the time, you'll be able to use that. All right. So it's almost like being able to use your notes. All right. When it comes to this, and I'll show you guys that. Actually, maybe I'll show you guys that in a little second in this video after we do this problem. All right. So the derivative of cosine is negative sine. Keep the inside the same, times the derivative of the inside, which is 4, and those are dx. All right, so we need all of du. There's sine 4x. There's our dx. What are we missing? A 4 and a negative. So I need a negative 4, which means I need a negative 1/4 on the outside. All right, so this and that are all my du. Now, the square root, this is u. Well, the square root of u is just u to the 1/2. So I integrate that. Negative 1/4 u to the 3/2. Take the reciprocal, so 3 goes on the bottom, the 2 is on top. So I get negative 2 parentheses cosine 4x to the 3/2 all over 12 plus c. Now, hopefully, this is, I probably wouldn't take off, but what you should realize is this, you can reduce, and that becomes a 6. So that would be the right answer right there. All right, so cosine 4x to the 3/2 over 6 plus c with a negative out in front. Okay. All right. Let's try this one right here. This one's a little special little guy, but you should be able to see if you can figure out what the u and the du are. All right, go ahead and try that now. Okay, so secant, tangent, one has 5, one has 1. So we're going to take the one that has the highest exponent. So it's going to be secant 2x. Okay, now to find the derivative of this, all right, to find the derivative of this, all right, hopefully you know what the derivative of secant 2x is, but if not, all right, let me show you what the formula sheet's going to look like. All right, so this is what the formula sheet's going to look like, okay? And the part that you guys are concerned with, the derivatives are on the left side, integral stuff's all on the right. This right here, for right now, is what you guys are concerned with. Look, derivative of sine, cosine, derivative of cosine, negative sine, tangent, secant squared, cotangent, negative cosecant, secant, secant u, tangent u, cosecant is negative cosecant, cotangent, all right? On this side, you are concerned with these parts, not all of them. This one, the integral of sine is negative cosine. Cosine is sine. Don't worry about this right now. We will do those. But then you have secant squared is tangent. Cosecant squared is negative cotangent. Secant u is this. That is that. Those are what, and you can use this, and I'm going to attach this to the classroom later on. And you'll have access to this anytime you want. If you do have a printer home, might not be a bad idea just to print this out. And then you could have it, for your use. Like I said, hopefully we get back to school at some point this year, and I will give you a nice colored copy of this that you guys can keep. All right. But yeah, it's a nice little thing. So for this problem, we were doing what? It was derivative secant. So it's right here, right? Now notice is secant u. U is whatever comes after it. So it's secant u, tangent u, which means like in this problem, secant 2x. It's secant 2x, tangent 2x. Then the du means take the derivative of the u, whatever comes after it. In this problem, is 2x. That kind of tells you the chain rule right here. All right. So going back to this, it's secant 2x. So it was secant tangent, right? So secant 2x, tangent 2x, and then we have times 2 dx. Where does this 2 come from? It's the derivative of whatever came after, which was the inside. All right. Now, this is what I said is a little different. Watch what happens. Okay. Now, we need all of this to be somewhere in here. Okay. Now, obviously, here is our tangent 2x dx. This part right here, we are just missing a 2, which means we're going to have 1/2 on the outside. Okay. Now, I need a secant 2x. Well, I have a secant 2x. I actually have how many of them? 5. All right. There's 5 secant 2x's, right? It's secant 2x, secant 2x, secant 2x, secant 2x, 5 times, right? So I need one of them as part of my du. So instead of being to the 5th, it's now to the 4th, because I use one of them as part of to substitute du. So now I don't have 5 secant 2x's, I just have 4. So it's going to be u to the 4th du. Okay? It's like because basically what it is, it's like there's 1, then I got another 1, it's 2, there's 3, there's 4, there's 5, and then we have what? Our tangent 2x dx, right? So what I basically did is obviously there's this part right here, but I needed this part as well. All right, and we obviously added a 2 in there as well. This is my du. All right, that's what is substituted here. Okay, so now what's left? 1, 2, 3, 4 of them. That's why this is to the 4th. Okay, so this type of problem is only going to happen if you have secant tangent and you have a situation here where the secant was the larger one. If you look at 18, we also had secant and tangent, but notice tangent was the larger one. So this is a special little case. We'll do more examples of ones like this, in practice on the worksheets before we ever take a quiz on this. Okay, so when I just integrate, now I'm just left with a nice little integration problem. 1/2 u to the, what is that, 5th over 5 plus c. So my answer is secant to the 5th 2x over 10 plus c. The mistake on this one is instead of putting u to the fourth, a lot of you are going to put u to the fifth. And that hopefully will change the more practice we do with this one. All right. All right. So we have 5 left here. We're not going to do all 5 of these. Let me pick 3 of them to do with you. All right. Now, 421, do me a favor and see if you can think what your u would be, and then see if you can get du. All right. So we have a situation, just looking at it. If you see something with a radical, pick what's on the inside. Whatever's on the inside. In this case, it's cosine 3x. What is the derivative of cosine? All right. Well, in case you forget, you could always look at your formula sheet. And what's the derivative of cosine? Oh, it's negative sine u du. All right. So it's negative sine u, meaning you rewrite this, times du, which is the derivative of the inside, which is 3. I'm going to put a dx after it. All right. So we have sine 3x dx. All right. We are missing the negative 3. So I'm going to add a negative 1/3 to the outside. Now, this is u. So I have the cube root of u on the bottom, which is really u to the 1/3. But since it's on the bottom, I need to bring it to the top, which is negative 1/3 du. All right. So it's on the bottom. That's why it's a negative exponent to bring it up. It was the cube root. That's why it's the 1/3. All right. So to integrate this, it's negative 1/3 u. What is 1/3? Negative 1/3 plus 1. Well, it's 2/3 with the 2 on the bottom and the 3 up top. These 3's will cancel. So I'm left with negative cosine 3x to the 2/3 over 2 plus c. All right? Because we add negative 1/3 plus 1 is 2/3. Then you put it over 2/3, but you can't do that. You got to do the reciprocal. That's why the 3's here. The 3 cancel with this 3, and the 2's down there. All right. Just so you know, also on this formula sheet, if you look at this, this is your power rule for integrals, u to the n. U to the n plus 1 over n plus 1. You add there. Right? There's actually your power rule for derivatives right there too. You subtract. All right. All right. 22, hopefully you notice that there's something different about this one. All the other ones we've done so far today has had 2 trig functions. This one has 1. Now, hopefully you also notice is that this is on the bottom. All right, this is on the bottom. So what is the reciprocal of cosine? All right, the reciprocal of cosine is secant. So 1 over cosine squared 9x is really the same thing as secant squared 9x. So that's the problem we're dealing with here. All right, so if you see 1 over something like this, most likely we had one like on the quiz when we first did integrals, where we had the trig on the bottom. Okay, you take the reciprocal of it, now you integrate. So now we have one trig function. Remember, if you just have one trig function, what do you make the u? You make it whatever comes after the trig function, 9x, which means my derivative is 9. Put the dx after it. So I have to add the 9 in there, which means I'm going to get, let me change colors here, 1/9 the integral of secant squared u du. Now, notice, we have a trig problem. Our u doesn't have trig in it, but our integral does. All of these other ones for a trig problem, our u had a trig problem, but when I wrote the integral, it doesn't. Always has that pattern. Now that you can use our formula sheet, 1/9 integral secant squared u du. You look here, where do you see secant squared? Secant squared, secant squared. Ah, here it is. All right, so the integral of secant squared u du is tangent u plus c. Great, so it's tangent. So it's 1/9, and then you just write tangent u plus c. And what's u? It's 1/9 tangent of u, which is 9x plus c. And there's your answer. All right, so you can see with the formula sheet, makes life a lot easier. Hopefully you guys know it already, but I think actually looking at the formula sheet will do enough problems. You'll sometimes not even have to look at it. All right. All right. Let's do last one we'll do. Let's pick 24. Okay. Now 24 is going to be very similar to what happened in 20. So I want to see if you can figure out what you should do for number 24. Go ahead. All right, let's see how you did. All right. Cosecant, cotangent. We have two trig functions, different powers. So our trig has to be in our u. Take the one with the highest exponent. Cosecant 3x. Now, the derivative of cosecant. If you forget, look at your formula sheet. Derivatives this side. Cosecant is negative cosecant cotangent. Great. So we do negative cosecant 3x cotangent 3x times the derivative of the inside. Don't forget about this. 3dx. Okay. So I need all of this in my integral. All right. Cotangent 3x dx. That's this and this. I need a 3. So all of this is right there. What am I missing? First of all, let me put the 1/3, and I also need to make it negative. Okay. I need a cosecant 3x. So there's a cosecant 3x. There's 6 of them. So I'm going to take one of them. So now there's only going to be 5 of them. All right. So one of these, along with this, is my du. And I'm left with cosecant 3x, which is my u. But instead of being 6 of them, now there's 5 of them. Okay. Very similar to what we did with this one. Now, this is going to happen with cosecant cotangent and possibly sometimes secant tangent. That's it. Won't happen with anything else. Okay. Doesn't mean it always happens with those. When you see one of these, it's going to be like this. But that's where your radar needs to be like, ooh, let me see if it's one of those. Okay. So now, once I have that, all right, I just integrate negative 1/3 u to the 6th over 6 plus c. And then I get negative cosecant 3x to the 6th power over 18 plus c. And there's your answer. All right. So just to close, all right, if you have a trig problem with substitution, all right, what I want you to ask yourself, is there one term, one function, or is there 2 of them? Is there 1 or 2 functions, trig functions? 1 trig, we'll call this 1 trig, 2 trig. Okay. So what I mean by that, 22 is an example of having 1 trig in it. Whenever that happens, u equals, really hard to write on this, whatever comes after the trig. Okay? And I'll write this up nicer for you one of the days coming up. All right? If there's 2, then you have 2 things to ask yourself. Do they have the same power? Or are they different power? All right? If they have the same power, all right? If they have the same power, then u is whatever comes after the trig. An example of that was back yesterday when, on number 14 here. Cosecant, cotangent, they have the same power, 1 and 1. So u was whatever came after the trig function, which was x cubed. All right, that would have been u in that problem. All right, today what we did is if they have different powers, all right, if they have different powers, u equals the trig with the highest exponent. The highest exponent. All right. So for example, this one, cosecant and cotangent, they had different exponents. One was 6, one was 1. You take the trig with the highest exponent. All right. We will be doing a couple days of practice with this. I would probably guess on a quiz maybe being on Friday for you guys. All right, that's tentative, but I'll keep you updated. Also, look out for I'll have some Zoom extra help sessions. Feel free to stop in and ask any questions that you have during that time. If you have any other questions before that, just please reach out, let me know, and anything you're having issues with, I'll try to help you out. All right. I hope you guys have a great day, and I'll be talking to you soon.